I'm really excited for this lesson. It's going to be helping us solve proportions with a new strategy called cross multiplication. Now, you're probably saying, Mr. Schmidt, you're always excited about every lesson, and you are right. I am excited about every lesson, but this one in particular is really fun because it helps us solve all the problems we've been working with really quickly, which means if you're working with proportions, you are working with real world problems. Now, that being said, this is a challenge lesson. So if you are a sixth grader watching this video, make sure you have talked to me if I want you to actually learn this lesson in sixth grade. So, what is a proportion? Well, a proportion is, you're going to be excited to know, something we've already been doing. So it's nothing new. A proportion is two equivalent ratios set equal to each other, which is exactly what we've been doing for the last three sections. In fact, you just took a quiz on proportions. We just didn't call them a proportion. So for example, 2/4 equals 1/2. This is a proportion. Very important. Another example could be 4/6 is equal to 8/12. This is a proportion. A proportion can have both fractions set equal. You can have one of these missing an x. It just must be two equivalent ratios set equal to each other. Now, this is what's important here, and I'm going to give you candy for bringing this to me. They must be set equal to each other. Therefore, you can only do cross multiplication if you have an equal sign. You bring that to me, you'll get one piece of candy or 5 SPs. So, the old way to solve proportions was finding a pattern to go from one fraction to the other fraction. For example, if I see on the bottom that 6 times 3 is equal to 18, 3 times 3 should then give us our x value, which is 9. Same pattern on the right, except this is where it got tricky. When we did this pattern, 4 times something equals 10, that something had to be a decimal. And now, just because, instead of going through the whole process to show you that 10/4 is equal to 2.5, I'm going to tell you that it is equal to 2.5, which means that y in this case will be 15. 2.5 times 6 is 15. The problem here is that this process takes a really long time. And what if the number times 4 is a really ugly decimal, or the value of y is a really ugly decimal? We need a new strategy to help us solve those types of problems. And so what we're learning here is cross multiplication, which can help us solve any proportion the same way, no matter what numbers we're given. So, when you have a proportion, which you must have an equal sign, we call it cross multiplication. And you learn with mathematicians that we are not very creative. Therefore, you put an x through the equal sign, and you multiply across that x. So, for example, I'm going to do 5 times x, which is just 5x. X being some number that we don't know yet, but it will be equal to something in a bit. Then we do 8 times 20 for the other part of the equal sign. Well, 5 times x we're just going to leave, but 8 times 20 is 160. That's step 1. Step 2 is we are going to divide both of these numbers by 5. Because if I do 5 divided by 5, I get 1x, which we just have 1x over here. And then I do 160 divided by 5. 5 times 3 is 15. 5 times 2 is 10, and there is no remainder. Therefore, our x must be 32. Now, we're going to go back and check, and I'm going to show you that the cross multiplication is still true. So now here's our actual proportion. We're going to put an x through the equal sign. 8 times 20, we already know, is 160. But here's the good news. 32 times 5 is also 160. Cross multiplication. You put an x through the equal sign, and you multiply across the equal sign. The other nice thing about this, if I put an x through the equal sign and it doesn't make a true statement, it means the fractions are not equal to each other. So if you ever have a problem where you don't know if they're equal, you can cross multiply to discover if they are equivalent ratios. So now we have the exact type of problem that cross multiplication is going to be incredibly helpful with. We have some pattern, 12 times something equals 15, but going through that process is very difficult. So we're going to cross multiply to solve this faster. 4 times 15 is going to be equal to 12 times some number c. 4 times 15, well, 15 times 2 is 30, and 30 times 2 is 60. Therefore, 4 times 15 is equal to 60. And that's equal to 12 times some number c. Well, there's two ways to solve this from here. You can either do the guess and check, 12 times 1, 12 times 2, 12 times 3 until you figure it out, or you can simply divide both numbers by 12. 12 divided by 12 gives us 1c, which is what we want. And 60 divided by 12 is actually 5, right on the nose, because it goes 12, 24, 36, 48, and then 60 on the nose. So our answer is 5 for C. We can plug this back in, and we can prove this is true two ways. We can either simplify both fractions, divide both of these by 4 to get 1/3, both of these by 5 to get 1/3, so it's true. Or, once again, we can use the new strategy. We have an equal sign. We can cross multiply. 4 times 15 is 60. 12 times 5, we just proved before, is also 60. Therefore, our answer must be 5 for C. And that's it. That's all of cross multiplying. It gets tougher from here when you're given numbers like this that have a decimal, but the process is always the same. So let's do one last one together. We have a proportion. We can cross multiply. 7 times 6 is equal to n times 8, or 8 times n. Now, this is not a whole number answer right away, so we have a bit of a problem, but that's okay. Because we're doing cross multiplication, it's actually a little bit easier to solve. So these are being multiplied. The opposite of multiplying by 8 is dividing by 8. So I get 1n is equal to this. To solve that, good thing we learned long division with decimals, because we need some decimals here. So 8 times 5 is 40. We bring our decimal up. 8 times 2 is 16. That's the closest multiple. Up, and here we go. We hit it right on the nose. 8 times 5 is exactly 40. Therefore, our value of n is 5 25/100, or 5 1/4. Both of those are the same. So we're going to write that over here. And now I can check to make sure it's right, just like I've been doing before. And now this is going to look really weird to have a decimal inside of a fraction, but it's certainly possible. And in fact, as I go into the retake video, we're going to have to go through examples where this is true. 7 times 6 is 42. And 5 and 25 hundredths times 8 is also 42. For the sake of time, I'm going to let you type that one into your calculator on your own. But our answer is true. So it must be 5 and 25 hundredths.